Okay, folks, this is in the section of the book entitled Force/Couple Systems, page 63, and it's dealing with a box on a shelf, and the box itself is generating 200 newtons, which would mean it's approximately 20 kilograms, and it's acting at a distance of 1.5 meters. And it says in the textbook that it is important for you to be able to convert a force into a force couple and back. This process is outlined in the example below. Now, it doesn't tell you why, which I think is not a very wise thing to do, to make a statement like that, a general statement, and not tell you why. I am assuming that in engineering, especially in the field of statics, where you're dealing with things that are static all the time, you'll find that, for instance, if you had a pole and it was designed for a freeway and you had some traffic lights on it, and the pole's here, and you were being asked to design the bracket. Okay, that's your bracket for holding up this whole assembly. Now, obviously, you've got two forces acting here, and you'd have couples and reactive couples and all sorts of things going on, and you want to know what's happening at this bracket. You know, what forces are acting at this bracket. So that might be a reason why you need to be able to convert this to what's known as a force couple. So you know what forces and couples are acting at the actual bracket in a location. Okay, so I'm assuming that is the reason why. So if that question mark came into your head, that's the reason. And later on, when you study statics in engineering, you'll find that you'll be doing this in 3 dimensions, and it's a lot more complex than it's given credit to in this textbook. But of course, this textbook we're trying to deal with every type of engineering, so we're just getting a taste for how statics operates. So first thing we want to do, if we want to do this conversion of a force into a force couple acting at the wall, and it's cantilevered, which means that at point A, where it meets the wall, really it would be going into the wall, but for all intents and purposes, that's where it ends, and that means that this is a fixed point. It can't go anywhere, it can't pivot. We're not dealing with a pivot, we're dealing with a fixed point. So when they say a cantilever, what they're really saying is that this point is as fixed as it can get. Okay, so a fixed point, it can't move, it can't rotate. So we do our, first thing we do is we do our free body diagram of the situation. So we know we have 200 newtons, and it's acting directly down, and it's acting at a distance of 1.5 meters. We don't need to modify our units because it's already in meters and newtons. Okay, so the first thing we need to do for this type of question is we need to, I'll just move it up a little bit, we need to move our force vector onto the wall, because basically what happens is if this force is acting down here, it's going to have the same effect when it reaches the wall. So I'll just get my pen going again. So what we do here is, it's always a good idea to label your forces. So we can say F1 is our 200 newtons acting down, and then we apply the same force here, and we're going to call it F2, which is 200 newtons. And then of course, for every action, there is an equal and opposite reaction. This is Newton's third law. So we've got F3 here, which equals the same, 200 newtons. So we now can see that we have a couple. We have a force acting up of 200 newtons and a force acting down, okay, here and here. That's going to create a rotation. So what we want to do is rub all that out. And we've also got a force acting down. So if we want to now draw the answer to this, what we do is we say we know that the force acting up and the force acting down is what creates our couple. So at the wall, we have a 200 Newton force acting down on the beam, on the shelf, sorry, and we have a couple which we designate with a circle like that, which is we need to work out what our couple is. So we know that the two forces F1 and F2, F1 equals F2 equals, and there goes the bell, equals 200 newtons. So moment of couple is equal to 200 by 1.5, and that moment of couple is equal to 300 Newton meters. Okay, so we write that here, 300 Newton meters, and that is your answer. Okay, you've got your couple and your force. So you've got a force couple at the wall. For the next question, we will take, we'll sort of reverse engineer that. We'll take a force couple at the wall and convert it to a force at a distance from the wall. See you in the next video.